Okay, number 8 asks, which is the lowest energy conformation for cyclohexane? So this one's pretty straightforward. Option A is chair. Let's just draw the chair really quick. And so what we need to understand about the chair is it does a couple of things. First, it allows for all of the carbons to obey the perfect tetrahedral geometry that they enjoy. For example, we've got 2 hydrogens right here. We can essentially imagine this as being a wedge bond and this as being a dash bond down to those other carbons. But however you want to visualize it, it has that perfect tetrahedral geometry with 109.5 degree bond angles. And then the other thing it does is that all of the Newman projections for all of these bonds would put the different alkyl groups as anti to one another. So for example, this carbon-carbon bond is anti to this carbon-carbon bond. And you can do that for all of the carbon-carbon bonds. So number 1, there are no eclipsing interactions. The alkyl are not eclipsing one another, or the hydrogens are not eclipsing one another. And also everything is anti to one another, which is specifically the best. There are not even any gauche interactions. All of the alkyl being anti to one another, all of the carbon centers being able to obey 109.5 degree bond angles, the flawless tetrahedral geometry that carbon atoms prefer. For those reasons, it is a chair. When you look at boat, twist boat, half chair, these are all configurations that produce eclipsing interactions or these other destabilizing effects, which is why a chair will pass through these configurations during a chair flip. When we go from one chair to the other chair, it passes through these configurations, but ultimately we'll get to the other chair because those are the 2 lowest energy conformations for cyclohexane for these reasons that we just described.